Hey, what's going on, guys? Today I'm very excited. I'd like to present you how to go through all the different steps from, well, a simple ID all the way to a real prototype that you can hold in your hands and actually use to play your favorite retro games. So that's the RetroBlock2 game console that I entirely designed, and I built the prototype, and I'd like to walk you through the different steps which leads to from, well, just an ID to an actual prototype. So I'm Pierre from AB Craft. I like to develop game consoles. That's actually not my first one. You can see here that's the RetroStone 2. It's a game console that I launched on Kickstarter, and I wanted to make a different version which is more comfortable to use when I play at home. So the idea is that it's SD card compatible between the two, so you can take the system from one directly to the other one and swap between them. If you want to go out, this is more handy and this is more comfortable. So here we have all the different components that make the RetroBlock2. So the first category of components are the 3D modeled parts. So you can see, for instance, the front case here, the back case, the buttons, the battery door, but also all the buttons and all the silicons. All those are actually made on parametric 3D modeled software. And so I didn't make all the buttons and also some silicons. These are actually pre-existing parts that I purchased directly. So actually I make only these silicons for the LNR buttons and all the other plastic parts. So this first category of parts are made on parametric 3D modeling software such as FreeCAD. FreeCAD is an awesome free and open source software that you can download right now and use for free. And I will show you right after we have a look at the other components. So the second category of components are the electronic boards, also called PCB. So those PCBs are a kind of board, and on top of which all the different connectors and components are positioned very precisely, and you have actual copper traces which connect each components with other components. So here that's the main board on which you have the processor, the RAM, and all the different connectors and so on. So this is a fairly complex PCB which has about 200 components, and those on the other side are very simple PCBs which has almost no components. Those PCBs are used for the different set of buttons. For instance, this is the ABXY buttons PCB, and then you have one for the D-pad and one for each joystick. And the reason is because the different PCBs are not positioned at the same place. So PCBs are very great, but one thing is that all the components are soldered on the same board, so it means that all the components are soldered on the same height, let's say. So you will see on the 3D models that the different buttons are not necessarily on the same height as the others, and thus the reason why we make several PCBs. Then the third kind of category of components, it's like general components, let's say. You have the speakers here, for example, the LCD. So those are off-the-shelf components, meaning that they are already ready and some manufacturers are selling them. So I just purchased those. The LCD has just a slight personalization, which is the picture is actually reversed by 180 degree, so it's upside down, and that's mainly because for the assembly on the RetroStone and the RetroBlock it's necessary. And then we have here the LCD protector, which is fully customized based on our shape, and the battery, which is also in fact very customized. You have two lithium cells inside a plastic housing that I designed also on FreeCAD, and you have a sticker around it, and you also have a small PCB which makes protection for the lithium battery, for instance overcharge protection, over discharge protection, and so on. So yeah, now let's have a look first at FreeCAD, which again is a free and open source software that you can download right now and learn to start using. And after we'll have a look at KiCad and also Inkscape in the end. So yeah, let's get started and have a look first at FreeCAD. So FreeCAD is a parametric 3D model software on which you can make pretty much any shape you want. And the idea behind is that you have a lot of different steps to make like basic shapes, but the more you go and the more it looks complex. So I won't make a full tutorial on how to use FreeCAD because there are already plenty on YouTube. So if you're interested to learn to use FreeCAD, you can check on YouTube for videos and explanation how to build your own models. But as you can see, you have the different features that we need for the game console, which means here, for instance, this is the place where the start button will be. Here it's for a speaker, and you can also see here this is the shape where we will be putting the LCD. It's exactly the shape of the LCD, so we can just pop it right in. And also here for the joystick and the D-pad and so on. And so you need to make all the different features inside and make sure everything fits correctly inside. So for instance, this is a screw pillar, so it just hold it's just the PCB, the main PCB, which fits on top of it, and the PCB also has a screw hole, so we can just put a screw and fix the PCB right there. So as I told you, the different PCB are not at the same height. That's why we have different PCB, and the most obvious example is here. For instance, you can see the joystick PCB is clearly not at the same height as the D-pad PCB, so we must have two different PCBs here. Yeah, so on the front you can see we have here a hole that has the shape of the PC protector. So actually what I did is export this shape as a 2D layout outline. So you can just export as a DXF, for example, which is a 2D file format, and then the 2D file format can be imported later on Inkscape, as I will show you. Well, I can show you right now. Here you can see the 2D shape has been imported here, and after that on Inkscape you can make vectorial pictures, which are needed to have very precise print, and you can just color fill and then put your text and so on, and this file afterward can be sent to the manufacturer of PC protector, which will make them as we've seen on the picture exactly on the shape you want. So that's pretty much it for this start. I can also give you a look at the back case, and but it's pretty much the same as the front case. You see you have the holes for the LNR buttons. Those shapes are to hold the silicone and the PCB of LNR buttons. This is the battery cavity you can see here, where the battery will rest, and the connector is here. You have screw holes to close the case together, and all the holes for the different connectors are there. So that's pretty much it. I won't be showing you all different parts because it's not very useful, but again, if you are interested in learning to make 3D models, to make your own game console, for instance, you can have a look on YouTube for FreeCAD tutorials, and it's fairly easy to learn it, so I encourage you to try. And for the PCB, They are made using a free and open source software, which is KiCad, and we'll have a quick look, but I won't be giving you a full tutorial on how to use KiCad, because there are already a lot of them on YouTube. So if you're interested, have a look on YouTube, search for KiCad tutorials, and you will find a lot of great tutorials. So I will just show you very quickly how it's made. So you actually have two main files, which is the schematic and the PCB file. The schematic is actually the logic behind the board. So you can see here, this is the joystick board, and the schematic just show the connection between the different components. So this is, for instance, the joystick, and the joystick is connected to a trace which is called ADC1, and ADC1 you can see is also connected here. So the software will know for the next step that this pin here right there must be connected to this one. So once you have finished the schematic, you move to the PCB file. So the PCB file is actually the real layout of the PCB. You can see you have the different layers which represent different things, but basically you draw the outline of your PCB, and then you position the connectors exactly where you want them to be. So for instance, the joystick has to be centered around the center of the hole on the plastic case. And you can see here on this PCB, I imported the 3D shape, the 2D shape of the front case in two different directions, because we have one joystick on each hole here, and the idea was that this PCB has to fit both joysticks. But yeah, and so here you can see you have the actual copper traces which are drawn on this part of the software. This is where you draw the actual copper which will connect all the connectors, all the components that you need to be connected together. So that's pretty much it. If you're interested in learning more about KiCad, I strongly suggest having a look at their website, and also on YouTube at tutorials, and it will help you getting started very quickly. So here you have it, how to design a complete game console with only open source software. And now let's have a look at the prototype and the different parts that we received and how we are going to assemble them. So here it is. I just received the first prototype from the factory. So we'll check what is inside the box and how the factory is sending me all the different parts of the prototype. So as you will see, there is all the different parts that we designed, and it's always a very nice feeling to finally get the prototypes, because you spend like months working on 3D models on the computer and on the PCB, and then when you have it in your hands, well, the first thing is that it actually does not feel as you expect usually. I'm quite surprised, because I kind of feared that it would feel very bulky and very big, and actually it feels quite nice, and it feels very nicely in the hand. So I'm pretty happy already with the results. So this is the 3D case, the 3D printed case. So inside you have the LCD, which they packed inside the case such that it does not get broken while shipping. And you can see this is the 3D case sample. So as you can see, it's not exactly the same as on the 3D models. For example, here you don't have the vibrating motor shape. That's because this part has been printed before. It's the previous version, and since I already made some corrections and I added the motors here. So well, basically you can see this is where the A, B, X, Y buttons will be, the D-pad button here, the two joystick, start, select, two speakers here, and on the back cavity you can see you have the holes for L and R buttons, and the cavity for the battery, and so on. So this is the main parts. So now the goal of this prototype will be to see if every component here fits correctly inside, and if there is any modifications that we need to do on the 3D or on the PCBs, so such that on production there won't be any issue if we proceed to production. So yeah, let's see what we have, what other parts we have here. So those are the L and R buttons. You can see here they will fit inside here. So I already tried, as you can see, to fit one button, and already I can see there is an issue here. It cannot be inserted, and we will need to remove a small part of material here, such that it can fit more easily. So that's the first thing that will need to be corrected. And yeah, so that's the LNR buttons. Then here we have the front glass protector. You can see it's actually exactly the shape as we designed it, with the round corners here that will fit perfectly here. And yeah, that should fit nicely on the case. We'll try that later. And then we have other 3D printed parts. So those are the battery door and the power button, you can see, and those are two GPIO buttons also. So the GPIO buttons will be here, plus and minus, probably for the brightness, and the power button here will be close to the USB-C connector. So yeah, let's see if the trapdoor for the battery can fit correctly. Well, it looks like it's good, but it's quite difficult to push all the way down. I think that it's because it's a 3D print, and you know, you have some some things which are not perfect in 3D printed parts, but nevertheless we'll have to double check the hinge here, that they fit correctly inside the holes here, because I think that's why it's actually not so smooth. So we'll check that later. First we'll see all the different parts. So that's it for the plastic parts. And now what we have here, so those are the small PCBs. So you can see we have different small PCB which are in fact buttons. So this is, for instance, the D-pad button. So the PCB itself should have exactly the correct shape to fit in those small pins. And these are the L and R buttons. They should fit inside those small hole. Let me show you. Yeah, those should fit inside here. There, like this. And when the button press, you see it will just press the shape of the button. So yeah, that fits pretty nicely. I will not push all the way down because it's actually to fit. So I fear that once it will be inside, we won't be able to remove it. So that's for the L and R buttons. And then what we have here, this is for the joysticks. So we have two joysticks, and so actually, to make things simpler, I made one PCB which should fit both place. So yeah, here it goes. Should be like this. Yeah, looks perfect. and the other will be here. So I think it should fit right there and there. Oh yeah, that looks good. So that's for the joystick. But here we have a joystick which are already soldered on the small joystick PCB, so you can see it will just fit in there like this, and then we will have a plastic cap which will make the whole thing move. So here are the plastic caps, so we can already try it, but we'll keep it for later. We'll first finish checking all the different parts. For me, it really feels good when I unbox the first prototype, because really when you spend so much time designing on the computer and then you receive the different parts. So those are the two small speakers. You see they will fit right there and they will connect to the main board with their small connectors. And then we have the ABXY button PCB. So this PCB will fit inside here, and it will be screwed to those two small screw pillars. And then we have some additional joystick parts, because we have found a supplier for two different models actually. So we will try both of those models and see which one is the best. And then we have some USB connectors, because we need to check which one is the best to connect to fit inside the case. And this is some cables. So because each of those small PCBs that I showed you before, you see you have small vias here, and so each one of these PCB will be soldered to one cable, and the cable will connect to the main board with those connectors. So we will have to solder all of those cables to the small PCBs and check if everything is okay. And now the main part of the prototype is the PCB. So we have two different pack of PCBs, because we will try two different Wi-Fi module actually, but otherwise it's the same PCB. So wow, that looks really nice. I mean, every time I receive an assembled PCB, it always feels pretty amazing. Like, you spend so much time working on the whole thing, that when you get it and that it works, especially when it works. When it does not work, it's not so exciting. But you can see the PCB fits perfectly in the case. You have volume wheel here, audio speaker here, the power button here, audio jack, GPIO buttons here, USB-C for charging here, SD card reader, the CPU obviously. Those are the different connectors. This is for the speaker, those for the different buttons, either the joystick and the other GPIO buttons. And then we have again some connectors for speaker and buttons. This is the battery connector, and this is the Wi-Fi module and antenna. So HDMI, USB, two USB here. And so the whole difficulty when you design such a project is that you have to position the connectors such that in the end you will be able to close the case. And as you can see here, we have a huge battery cavity, and the battery cavity comes very close to the inner components. It's maybe only 2 millimeters between the PCB and the battery components. So it's actually, you have to be very precise in the positioning of the different connectors, and that's actually one of the most difficult parts, making sure that everything will fit perfectly. And as you can see, for instance, the to USB is very big, so it reaches almost the top of the case, and it fits right between the LNR button and the battery cavity. It fits very, very neatly, and there wasn't anywhere else we could have put this these connectors. The same goes for the Ethernet connector. As you can see, it's very big, and actually it fits here, but very tightly. So we'll check everything assembled correctly anyway. But so that's pretty much it. You can see all the different components, and now we'll get started soldering and assembling the different things, and we'll see if there is any mistakes that needs to be corrected, or if everything is okay, and then we can make a new prototype for the 3D case to check again, is everything okay, before going into injection mold making, because once you make the injection mold, it's much more complicated to modify anything. Now we are going to need to do something more complicated. So we discovered on the first test that we made an error on the assembly. You see those two small components here, the one just above R24 and the one above. Well, they are actually reversed, so the LCD does not work this way. So we have to unsolder those two small components and then replace them with each other. So this is going to be quite difficult because it's really small components, and yeah, I hope we can make it so that it should still be possible. So we'll fix the PCB with tape such that it does not move. So yes, the repair is fine. The LCD is working correctly now. So I actually failed on 2 PCBs out of the 4 PCBs that I got, because it was actually really difficult to fix this issue. So time for some painting. So I just tried on a shell, a plastic shell that I have from an old controller, and it seems pretty okay. So we can now move ahead and try to paint the parts. So we'll start with the battery door. Yeah, we'll just use this to be able to go all around it. Yeah, we can even put some paint on the back first. The back does not need to be perfect, but if it can already have some paint, it's better than nothing. So now we'll just yeah, I think that's okay. Keep painting here. I just put this in order to be able to paint all around it. I think it could be worse. Yeah, it's definitely not so bad. Yeah, I think this will be okay. And now we'll paint those parts, but they will be in gray. So I'm going to use the gray color for those buttons, and we'll be able to get started. First, I need to shake it for 60 seconds. Okay, now that the paint has dried, the result looks actually pretty nice. I put some paint on the inside, though not perfectly because it's not really important, but it's just showing better on the camera because when it was white, it was very reflective. So now we'll just go ahead and assemble all those pieces together, and we'll start with the LNR buttons and assemble them to the back case, as this might be a little tricky because you can see the buttons are actually pretty big, and I put this kind of pillar right there where the PCB and the silicone will be inserted, but the space between the case and this pillar is very small, so this was a bad design idea. So I actually already done that on the 3D model. I will just push this pillar a little bit this way, maybe 5 millimeters. But I already assembled the LNR buttons, so it should still be possible to get them inside. Let's see if we can successfully insert them. Yeah. So that's definitely not the easiest, but it can work. But also another thing that I will probably modify is the way those two buttons are designed. First, I made those two as separated parts, and the idea was that each of them should be able to move freely on the axis, because I don't want that pushing one button push the two buttons together. But this makes a rather complex design, and I fear that it may not last enough. So I will just try to make those two buttons only one part and see if they can click independently. So let's insert the R1 button. There we go. And now R2 should go right there. Right. Yeah, that's definitely not perfect, because you see on the assembly line it cannot be so difficult, because the worker, he should just have to do something pretty simple. And you know, if he breaks one, or if he breaks a lot of pieces, then it's not it's not fine. So yeah, that definitely needs to have some rework. And also with the paint, it's not moving as well as it was moving before. So this will need to do a little bit of modification of the design of those two of the LNR buttons. Okay, so I just finished to insert both buttons, and I had to add some thread here, because the idea of this hinge system for the buttons was have to have something clap shut here in order to both buttons be fixed. But in 3D printed it was too small, and the plastic is brittle, so the hinge system didn't worked as 3D print. But anyway, I think we'll change this this design here, so it doesn't really matter now. So both buttons are moving correctly, and so we can move forward. So now we'll apply the silicones. So those are soft material with you can see here the black part is actually a conductive material. So the idea is when you push the button, it press here, and the conductive pad will make contact with the small PCBs here, and thus the CPU of the game console can register that you press the button. So we can just insert this here. You see in this pillar shape, and see if we can insert it all the way down. So you can see the top button here aligns correctly, and you see it aligns perfectly with the plastic. So when you press here, it press the silicone button, and as there will be the PCB beside, and the fact that the silicone is soft also push back the button when it's pressed. So for the bottom button, it's hard to see, but I think it's not correctly aligned, so I will just now we'll go to the front case. We'll put the back case aside for a moment, and okay, the first thing that we'll do is to apply the screen PC protector. So we'll start by removing the peel. I think there's some kind of, there you go. So we'll also clean the cavity for this PC protector, such that there is no dust which comes, and we'll try to be careful not to touch it, because we don't want any mark or anything like that inside, on the inside of the game console. And we can also remove the front plastic. There you go. Oh, that's actually the face which will go here. Okay. Well, that fits very well. Now we'll go, oh, it's actually, there is no sticker, so we need to add some double face tape here. So yeah, just took some time to find a double face tape, and we'll apply some on the edge of the PC protector. So let's do that. We'll just cut a small band of there. Now we'll try to remove dust and any mark that we put on the protector. There, that's nice. Okay, and now we can apply it here. And apply some pressure such that it sticks correctly. Well, that's the first step. So now we'll double check that there isn't any mark. So to make sure, we'll also clean the outside, because it's difficult to say if the mark is in the inside or the outside. So first we'll make this face clean, then we'll clean this very carefully, because we actually, once we apply the LCD, we won't be able to see anymore, to access anymore, to remove the dust. Well, we'll be able, but we'll have to deassemble. So the point is okay. So now the LCD itself. So you can see there is also a protective film here that we need to remove, and then we'll just apply it in the cavity. You see there is a square cavity which has the correct size for the LCD, so we just put it here, in here, where it fits neatly, and then, well, let's start to look like a game console. So okay, now we'll need to put the speakers, L&R buttons. So L&R buttons, we'll actually use the same one as on the retro stone, and we'll just cut it in half and put each half on each side like this. And the speakers there, and we just apply them here and on the other side. So for the speakers, we'll have to increase the depth of this because we need more space between the speaker and the PCB. I already had a try to see what needs to be done, so that's one thing. And then we'll put the plastic part for the D-pad here, and the silicone for the D-pad also, which fits here. So for this part, we also have to make some modification, because it doesn't fit correctly currently. So we'll have to make some modifications, but we'll just try to put it such that it fits, it still fits inside, and we'll modify the 3D such that it can fit perfectly for the next prototype. There we go. And then I'm not sure it's actually straight. Well, it should be okay. So we'll have to put the D-pad PCB now. So let's try to... Yeah, it's not that straight. So this will need to remove a little bit here also. So I can remove a little bit of silicone there, and we'll modify the 3D such that this will be corrected as well. There we go. So we'll try to put the D-pad here. it. You see the PCB should, you have a hole here and it should be fitting on this plastic pin, but again, as it's 3D printed, it's not very precise, so currently it does not fit, so we'll try to just increase the size of the hole here such that we can assemble the prototype. And let's see if this is enough. Let's just remove that because it doesn't fit correctly, so it keeps moving, so we'll need to fix that. And there also it will need some adjustments. Well, this looks better. And now the okay, so actually there is here something which is too big to fit inside, so we'll have to remove that. There you go. Okay, so now it can fit. So yes, we are going to put the screw here to secure the PCB down. So actually on this prototype there is only one screw here, which means when you push the D-pad, when you push down, it will push the PCB a little bit. So I already went ahead and modified the new 3D model such that there will be one screw here and one screw on the other side, such that it's really firm and it won't move at all. So then we have here, we can put the joystick here. Before putting the joystick, we need to put the cap, the joystick cap. That will be enough. And then we will also screw this PCB down. So now we are going to put the main PCB, and we need to connect the LCD here. So we'll go ahead and connect that first. Close the connector, and let's not forget about this speaker here. We are going to use some foam, which is an insulating foam. So the idea is that it will just insulate the speaker from the PCBs, such that it doesn't touch anything that it shouldn't touch. So let's just put that like this. Here, okay. I think we have everything now, so we can put the main PCB in place. We need to put these buttons and the PCB, so we'll just put the buttons in there. Then we apply the silicone on top of them. And we have the small PCB here, which will fit on top of that. There we have it. So this is the PCB for the A, B, X, Y buttons. And now we need to make sure the PCB is fitting correctly. We have 3 screws to hold the PCB, the main PCB, such that it won't be moving. Okay, so now we need to connect all the different cables. So this is the first speaker. Now we need to add the LNR button PCB. So the cables are not the same length because the connector is on one side, so we have to make sure we put the correct PCB in the correct place, so it will connect here. So the short cable should go here. Okay, all the way inside, and the same goes for this one, with the conductive pad in front of the silicone. So we just push this one down here, and that's it. So we can connect the wire. There we go. So as I told you, you see this circular shape, they will just push in the middle of the joystick. And the same goes here. This circular shape will go on the middle. So we have to clear those small PCB from any wires. So we'll just have to push the wires such that they go somewhere else. Nice. Now we just have to put those small plastic buttons here. Well, it actually fit inside, so that's good. And so now all we have to do is to close the case, and those axes from the LNR buttons, they have to fit inside those small holes in the PCB. I don't know if we can see them clearly. You can see here we have a hole that is the correct diameter for this, and the same here. So we have to fit these inside while we close, and it should be that should be the last step for this assembly. Okay, so we are back. I just had trouble to get the PCB really flat where it should be, and I found several little issues that will be addressed. So the USB here had some trouble to fit inside, really inside the case, so it was preventing that. There was also this PCB which was overlapping, as we said before, so this I cut it such that it can fit now. And so now we are back to the point where we try to close the case, and we'll see how it goes. So let's give it a go. So again, we have to put these inside the small holes on the PCBs, so it should be doable, I think, and we'll see how it. Yeah, you see now it can close completely, so we find the root problem of that we were having here. And what about the other side? Well, something is also preventing closing here, but I'm not sure what could be preventing. Let's have a look. Come here. Oh, yeah, of course, now I cannot open it anymore. There you go. So let's see what happens when I close. Oh, okay. You see this cable? It was stuck inside. It was stuck where the case was supposed to be closed. So that should be okay now. Let's go again for one more try. Yeah, that's okay on this side. And it's okay on the other side. Well, it looks like we have everything now. So we'll just put the screws. Let's see if it's closed everywhere. Yeah. And there you have it. It's now fully assembled, and it's working very well. There is only a slight issue with the audio speakers, because they are picking some white noise. So I plugged in the earphones such that well, we don't have the white noise while shooting the video. So obviously we'll need to check what is happening here, and how and why the LNR speakers are picking white noise, and fix that issue. But besides that, there is only very few things to fix. One of them was that the joystick was not the same direction as on RetroStone 2, meaning that if you went right, then it was going left with the settings from RetroStone 2. So because we want some consistency between the two devices, I will need to inverse the direction on the hardware level, such that you can really plug and play the SD card from the RetroStone 2 directly inside the RetroBlock2. So, well, that's pretty much it. You can see you have all the connectors here. You can see the case is not closing perfectly, because actually we have here a clip which is not very well done on the 3D printed parts. So it's not clipping actually correctly, but that should not be a problem in production. So, and also we'll probably add one or two clips more here, and the same for the bottom. You can see, yeah, there's a clip here which doesn't close correctly, but we'll also add one clip on each side here and here. And here it's a little bit ugly because the SD card hole was not positioned perfectly. There was 1 millimeter gap, so we fixed that on the 3D model too. And well, the battery is the same as on the RetroStone 2, so it's a removable battery, and that's pretty nice also, because you can swap between the two devices, the RetroStone and the RetroBlock. And yeah, the battery door is here, but as it's 3D printed, it cannot close correctly, but it won't be a problem also on the injected part. So I won't force because I don't want to break it actually. And that's pretty much it. So let's have a look at the device itself. Having said that, so you have here two GPIO buttons, which are actually the brightness control from the screen. I don't know if you can see on the camera, but the screen is dimming and then getting brighter. So we'll just put it back for the camera there. This is the on-off switch. The SD card, you can connect and unconnect the SD card very easily between the RetroBlock and the RetroStone. You have a sound wheel here, audio jack here. The D-pad you can see is not is much bigger and actually more comfortable to use than you would expect from such a handheld. So that's actually the same D-pad as on the RetroStone 2, and yeah, we use that part because it's just much more comfortable than the other one we could have used. And here we have two LNR buttons on each side. This is a Ethernet connector here, 3 USB ports to connect USB gamepads, and HDMI out. And well, that's pretty much it. So if you enjoyed this video and you'd like maybe to get one for yourself, we'll probably launch I will probably launch that on Kickstarter in about 1 month or so, once every hardware problem is solved. So if you're interested, you can you can subscribe to the website mailing lists, such that you will get an email when we launch and be able to get the early bird prices. So well, thanks for watching, and I hope you enjoyed it.